Hi everybody, this lesson is on adding and subtracting fractions. If you haven't already though, I would highly recommend that you watch my video on reducing and equivalent fractions, as well as my video on mixed fractions and improper fractions, just to kind of give you a bit of an idea of the types of fractions before going right into operations with fractions. So on this screen right now, you'll notice that I have three pretty important rules that I'm going to need you to keep in your minds as we're doing this video. So the first thing that I want you to know is that you can add or subtract any kind of fractions. So you can add and subtract proper with proper, proper with improper, improper with mixed, mixed and mixed. It doesn't actually matter. What does matter, however, is that no matter what you are adding or subtracting, the fractions two or more need to have a common denominator, also known as an identical bottom number, which we're going to talk about in a second, obviously with some examples. And the thing about adding and subtracting fractions is that when you're only actually adding and subtracting the numerators or the tops of the fractions. The denominator never changes, kind of like when we're going from mixed to improper and improper to mixed, the denominator never changed. In this case, the denominator also doesn't change. So let's go ahead and do some just very simple examples. So the first thing that is very common for people to learn about is just like fractions, fractions that already have the same denominator, just to kind of get you into the hang of what the operation does. So what I have here are three different examples, and you'll notice that this one here deals with, the number one deals with two proper fractions, whereas these ones deal with two mixed, and this one is actually a mixed with an improper, mixed with an improper. No big deal. I wanted to just kind of prove to you or show you that you could add and subtract anything you'd like. So going ahead here, a few things that you need to keep in mind. Thing number one is they have to have the same bottoms. And in this case, on purpose, I did give you the same bottom, same denominator. So we have a denominator of 4, which is great. So we can go ahead and add. When you're adding or subtracting, you only add the numerators or subtract the numerators. You don't look at the denominator when you're subtracting. Often this is a tough thing for some students to get, but you're actually only doing the top. So easily here, 1 plus 2 is 3. The other thing that I told you in the first slide here was that nothing changes about the denominator. So if it was 4 from the get-go, it's 4 at the end, and the answer to 1/4 plus 2/4 is 3/4. So that's pretty simple. When you go into, say, two mixed fractions, now you're dealing with whole numbers as well as fractions, and in this case, they are proper fractions. Again, not a big deal. The whole numbers is very simply, you just add the whole numbers together, right? So you would do 1 here, 1 plus 3, which gives you 4. No need for common denominators here. They're whole numbers. You just do 1 plus 3. Done. Now looking at the proper fractions here that I've highlighted in yellow, you're going to, again, add the numerators only. And in yellow, the numerators are 1 and 2, which added together gives you 3. And just like I said earlier and on the first slide, nothing changes about the denominator. It is still 7. And the answer to 1 and 1/7 plus 3 and 2/7 gives me 4 wholes and 3/7. And I'd also just like to point out that these are reduced, right? 3/7 is reduced to lowest terms. This is a prime number, so is this. The only thing they can divide by is 1. I'm happy. And that's it. Now let's do some subtracting. So you'll notice here that I have two mixed, and as I mentioned earlier, this is a mixed with an improper and a mixed with an improper, but like I said, it doesn't matter. We're going to change it up if we need to at the end, right? We're going to make sure that we have proper and mixed fractions at the end for our final answer, but for now, let's just go ahead and do the subtraction. So just like the mixed fraction we had in number 2, we're going to look at our whole numbers, but remembering that we are subtracting. So if we do 3 wholes minus 2 wholes, you get 1 whole. And then we're going to look at our fractions. So I'm really happy these fractions here have common denominators. They each have a 3 on the bottom, which is great, which means that I can actually physically go ahead and do the top. So if I do 10 minus 7, and I'll once again highlight it in yellow just to give you a better visual here, 10 minus 7, because we're subtracting, is 3. And of course, we're keeping the denominator, which is also 3. So what happens in this case? And this can happen when you're adding, this can happen when you're subtracting. What happens in this case? 1 and 3/3. So this 3 over 3 actually means this is a whole. So this is an entire pizza. So what happens is we actually need to combine or add it to the original whole that we had to begin with. So it's kind of like we're doing 1 and 1, which again we can just add together. So it's one whole and another whole. That means we have 2 wholes. And the answer is just 2. You could just say it's 2. But I hope that you see that when you're given a fraction whose top and bottom, numerator and denominator, are the exact same thing, it just means that you have a full whole. And just to kind of go a little bit further, because I don't think that I said it in any video, just to draw it for you, if you were to be given a chocolate bar, in this case it's a red chocolate bar, but if you were to be given a chocolate bar, and we'll pretend like it's the same length everywhere. So if we were to give 3, 1, 2, 3, you'll notice that I'm shading in the whole chocolate bar. So 3 over 3 is just the same thing as one whole chocolate bar. Okay, so this is adding and subtracting fractions that already have the same denominator, which is great. However, chances are you won't always be given something like this. So let's talk about adding and subtracting fractions that don't have the same denominator. We call these unlike fractions. And I've put here as a note in red that you need to remember that you need a common denominator. You're going to hear me, if you're in my class, say this a lot. You're going to hear your teacher say that a lot. You need to have the same base, the same bottom. So go back to what I spoke to you about in an earlier lesson about equivalent fractions. Fractions like here, 1/2 and 1/3, can actually be represented in many different ways. In my video on equivalent fractions, I proved to you that I could have 1/2 look something like 3/6, which is the same thing as 6/12, and et cetera, et cetera, et cetera. A fraction doesn't necessarily need to be represented in one way. And the reason why this is important is because you're going to have to kind of whip out your knowledge of equivalent fractions in order for you to actually add and subtract unlike denominators or fractions with unlike denominators. So here's the issue. We have a 2 here and we have a 3 here, and we cannot actually, it is illegal for us right now to add the tops. We need to make these look the same. So what is a good way of doing it is you can ask yourself, okay, what is a number that both 2 and 3 go into? Or we could also ask ourselves, what is the lowest common multiple of 2 and 3? Lots of different ways that you could say that. If you don't know what lowest common multiple is, feel free to watch my video on it. But basically, I know that both 2 and 3 go into a few numbers. They go into 6, they go into 12, they go into 18, and so on. There's many different numbers that they all go into. But for the sake of reducing and so on, we're going to use the lowest common multiple, which is 6. Now don't worry if you don't use the lowest common multiple, because like I said, you could just go ahead and reduce at the end. It doesn't matter. All I need from you is a number that both of these denominators go into. So just for the sake of this video, we're going to say that they both go into 6. Great. Which means that my goal is to make the denominators now look like this. So for the first fraction, in order for me to do that, and let me change colors here, I'll change it to a dark green so you can see. In order for me to get to 6, I had to multiply this 2 by 3. But like equivalent fractions, whatever you do to the bottom, you have to do to the top, and vice versa. So if I did the 2 times 3, I also need to do the 1 times 3, which means that this becomes 3 over 6. Same thing for my 1/3. In order for me to get from this 3 to this 6, I actually had to do 3 times 2. And we're always dealing with multiplication when we're dealing with equivalent fractions. And whatever you do to the bottom, you have to do to the top. So you get something that looks like this. And once again, we are adding. And then this means that we're good to go. We have a common denominator, which is 6, and we can now add our numerators, which are 3 and 2. 3 plus 2 is 5, and you keep the denominator, it never changes. And our final answer is 5/6. And this is reduced, so we don't have anything else to do. So now let's do another example. So in this example, we once again don't have the same denominator. We have a 5 over here and a 10 over here, not so good. So we have to ask ourselves, okay, what is a number, or what is a common multiple of both 5 and 10? And you're probably thinking of things like 20. 20 works. What else? 30 works, right? 50 works, so on. But if we're dealing with the smallest one to save us time, you can actually make this 5 look like this 10, meaning you don't actually need to change anything about the second fraction if you can make the first fraction look like it. So I hope that you know that if I do 5 times 2, I get 10. So I don't actually need to do anything to the second fraction because I already have the denominator I want, which is 10. For the first fraction, though, the 2/5, because I had to multiply that 5 by 2, I'm also going to have to multiply the top as well by 2. So now I have an equivalent fraction to my 2/5, which is 4/10, and I didn't move or do anything to the second fraction because it already had the denominator I was looking for. And now to finish off this question, you always keep the denominator and you add across the top. 4 plus 3 is 7. And 7/10 is once again reduced. So we are done. Now let's do one last question here. And so you'll notice here that we have, again, two mixed fractions. And I'm going to show you at the end of this video actually an example of a fraction if you are not into negative numbers right now. If you're not into negative numbers, your students aren't into negative numbers, it might be a good idea for you to see the example at the end of this video, which deals with a negative number. But alas, let's do this question. So you have two fractions. One has a whole, they're mixed, and one has a fraction. So just like in the last examples, you're not going to do too much to the whole numbers because they're there, you're going to subtract them. But we have an issue where this has a 4 and this has a 10, and you're like, this can't work. I cannot do anything to this because I need a common denominator. So the thing is that the whole numbers don't change. It's just the fractions that change. Now, just off the top of my head, I'm like, man, I don't actually know, maybe what 4 and 10, both go into. So a helpful trick that I usually teach my students is, in order for you to just save yourself some time, say, if you're not sure what a common denominator is, multiply each denominator by each other. So the first denominator is 4, we'll multiply it by the second one, which is 10, and we'll do the same thing to the 10 and multiply it by the first denominator, which is 4. Works every time, but you have to remember that whatever you do to the bottom, you also have to do to the top. So what happens is, again, nothing changes about my whole number, but this becomes 30 over 40. And nothing changes about my second whole number, but this becomes 4 over 40. Now, full disclosure, you could have easily done a denominator of 20, right? You could have done 4 times 5 and 10 times 2. You could have done a common denominator of 20. There's many different denominators that you could have used. I'm just using this as an example. So let's just go right ahead to it. So in this case here, we are going to do the whole numbers first. 2 minus 1, and let me highlight it for you here. 2 minus 1 is 1. So we know our whole numbers, good. Now if we go to our fractions, we're happy because we have a common denominator, which is going to stay the same, it never changes. And then we're going to do 30 minus 4, and 30 minus 4 is 26. So we have something that looks like this, but we are not totally done because we have to change this because this is not reduced. So we definitely need to reduce this worksheet, or this fraction. And I'm not quite sure, but I do know that both 26 and 40 divide by 2. I know this because they are even numbers, and so I know that they both divide by 2. So by going a little bit further, I know that 26 divided by 2 is 13, and 40 divided by 2 is 20. And I can confidently say that these are, this is reduced because this is a prime number, and I can't do much more to it. And that is essentially the gist of adding and subtracting unlike fractions. Of course, I only used 2 fractions, but you can add and subtract several different fractions in a row so long as they have the same denominator. Now, I'm going to show you one final example, and this is for students and or teachers who have not yet taught negative numbers to their students and perhaps need to subtract in a different way. So I am going to let you know that there's another way of doing this called borrowing, but that will be in another video lesson. You can borrow from whole numbers. But what happens if, say, we are given something like, and I'm going to say here, special case of subtraction, just to make sure that we cover this. Say you're given an example that looks like 18 and 1/4 minus 13 and 7/9. So once again, just like every other example we gave, I hope that you see that our denominators here are not the same. So we're going to have to make them the same. Let's use the trick that I just showed you in the last question, where I said that the best way for you to do this if you're not quite sure, I'm going to change colors here, is multiply the first denominator by the second denominator and multiply the second denominator by the first denominator. And that'll literally get it every time. So what happens here is we get 18, nothing changes, 9 over 36, minus 13, nothing changes, 28 over 36. Now, if you know integers, you could do this no problem. You do 9 minus 28, you get a negative number. But when you're dealing with fractions, specifically with things like baking, cooking, you might not want a negative number. You might want, just a regular mixed fraction. So in order to do this, and I'm going to kind of say here, as a little note, 9 minus 28 equals a negative number. You might not know what this is, or you might not want it. So we are going to instead change to improper. So this is a mixed fraction right now, so we're going to change it to an improper fraction. And to do that, as a quick crash course, you multiply the whole number by the denominator and you add the numerator. So multiply this and then add. And you keep the denominator, right? Nothing changes about the denominator. So they're both going to be under 36. And we're still subtracting. So now let's do some math. If I do 18 times 36 plus 9, I get 657. And if I do 13 times 36 plus 28, I get 496. So no big deal. We're going to just subtract across the top, and we're going to get 161 over 36. Now that's kind of nicer because we don't have a negative number, except in my class, as I've said, I do prefer answers to be mixed and reduced. So we're going to change this into a mixed fraction by dividing. So if we do 36, or ask ourselves, how many times does 36 go into 161 whole times? It goes in 4 whole times. And then we're going to do some quick division, right? So we do 36, oops, that's not right. You're going to do 36 times 4, which gives me 144. And then I have a remainder here of 17. This is my remainder. Which then means, let's do another here. Our 4 is our whole number. Our 17, which is our remainder, goes up here. And nothing changes about our 36. So we have just changed, we've done a lot of work actually for this question. We changed mixed to improper, then improper to mixed, but we were also able to subtract without negative numbers, which is great and very, very helpful for us. So that's, again, if you don't like negative numbers, or maybe don't even know what a negative number is right now. So this is the gist of adding and subtracting fractions, but I did want to remind you of the 3 rules that I had written at the beginning of this lesson, which is you can add and subtract any type of fraction. You always need to have a common denominator. and you can only add and subtract the tops, the numerators, but you keep the denominator. And I wrote here that the denominator never changes, but of course, when you're reducing your final answer, it will. For the sake of adding and subtracting fractions, though, before reducing, it never changes. And that is adding and subtracting fractions.